Today, we're going to learn about Georg Ohm and his famous law that relates voltage, current, and resistance in an electrical circuit. Before we begin, make sure to subscribe so you don't miss out on any of our upcoming videos. Let's dive in. In 1827, a German physicist Georg Simon Ohm discovered the relationship between the voltage applied to a conductor and the resulting electric current. This relationship is now known as Ohm's law. In simple terms, Ohm's law states that the current through a conductor between 2 points is directly proportional to the voltage applied across the 2 points and inversely proportional to the resistance between them. Let's break down this definition. We have 3 main components in an electric circuit: voltage, current, and resistance. Voltage is the electrical pressure that pushes the electrons or current through a circuit. It is measured in volts. Current is the flow of electric charge, which is measured in amps or ampere. Resistance is the opposition to the flow of current, and it is measured in ohms. Ohm's law shows the relationship between these 3 quantities. If we increase the voltage, the current will increase proportionally. If we increase the resistance, the current will decrease proportionally. The formula for Ohm's law is V equals I times R, where V represents voltage, I represents current, and R represents resistance. Before we move on, let's see an example. Suppose we have a circuit with a voltage of 12 volts and a resistance of 4 ohms. What is the current flowing through the circuit? Using Ohm's law, we can rearrange the formula to solve for current, which is I equals V over R. So I equals 12 volts over 4 ohms, which equals 3 amps. Therefore, the current flowing through the circuit is 3 amps. Now let's look at another example. Suppose we have a circuit with a voltage of 230 volts and a current of 5 amps. What is the resistance of the circuit? Using Ohm's law, we can rearrange the formula to solve for resistance, which is R equals V over I. So R equals 230 volts over 5 amps, which equals 46 ohms. Therefore, the resistance of the circuit is 46 ohms. In addition to the formula, there are also some rules to remember when dealing with circuits and solving problems using Ohm's law. The first rule is that the voltage, current, and resistance are all related. If one of the values changes, the other 2 values will also change. The second rule is that the current is split when it encounters a junction or a node. At a node, the incoming current is equal to the sum of the currents leaving the node. The third rule is that the voltage is divided when it encounters a series resistor. At a series resistor, the voltage drop across each resistor is proportional to its resistance. Kirchhoff's laws are a set of rules that govern the behavior of currents and voltages in electrical circuits. Kirchhoff's current law, also known as Kirchhoff's first law, states that the algebraic sum of currents entering a node is equal to 0. In other words, the total current flowing into a junction or a node is equal to the total current flowing out of the node. This law is based on the conservation of charge. Kirchhoff's voltage law, also known as Kirchhoff's second law, states that the algebraic sum of the voltages around any closed loop in a circuit is equal to 0. In other words, the sum of the voltage rises minus the voltage drops in a closed loop is equal to 0. This law is based on the conservation of energy. These laws are named after German physicist Gustav Kirchhoff, who proposed them in 1845. They are fundamental to the analysis of electrical circuits and are used to solve for unknown voltages and currents in complex circuits. We hope you found this video helpful. If you did, please leave a like and comment below to let us know what you want to learn next. Don't forget to subscribe so you never miss out on any of our upcoming videos. Thanks for watching. See you next time.